Yeah, yeah.
Yeah. Yeah.
Oh. But he doesn't actually have opposite squat in the zebra.
Oh,
No. Are you looking for?
yes.
Yeah, so there's a guy hiding, the other little guy. Thank you.
How's it going?
Good, how are you?
I'm all right.
Question for you.
Okay.
It's all about reproducibility. I think that's how that works.
I mean,
It's got
you-
a time course.
yeah, you
So
could
you've
do-
got
Yeah,
all the information you need. It's just not.
yeah, and you can run, like, I think there's ways that you can run your stats to sort of take into account that it's like a time course.
Yeah, yeah.
Although I don't know if like the running the stats like a time course assumes that your time points are from the same exact sample.
They are. No, so it
That's
doesn't,
right.
it doesn't matter.
They're not,
Yeah.
So it's like,
Um,
I've been thinking about that sort of too, because there's like a time course to when it's the same as data.
Yeah.
And I think the right move might be to do like online ratio test. Where you do the model that has like
yeah.
if you have a design that's like fully balanced, I think that would work. So like if you have three conditions or whatever, and you make a grid, like here are my three conditions, 3x3, you have like every single square is filled in.
Okay.
You have like
I have no. I have the only condition I have.
Oh, great.
Yeah.
Then yeah, that's very straightforward.
Yeah.
I was assuming there was like time and condition and you wanted to see if there was like a difference
Well, I've given
over
all the-
time or some such.
I've done pairwise comparisons between all time points. I think he just wants to know, can we identify? With this set of genes, what are they plotting the genes over time?
You still might want to be.
It's like,
You still need like the ratio, but I would have to log it to this, like, I think the. It would be, because maybe it's going to be like the right. There's a dose of that. So I think,
And like, you can't dumb it down in a way that I understand.
and Jordan was probably just need like knows a lot of stats and not specifically about how it's people most good.
Yeah, okay, perfect, that's great of you. Cause yeah, Jordan just went straight over my head so quick, I was like,
Yeah.
what is a gene? Let's reel this.
Yeah, I would like to put together this like.
And then.
Here's our question, here's what it looks like. Because then you can literally get August to be like. Here's the one you use.
I mean, that's the,
Not do it for you, but.
but dumb
Do a
it
lot
down
of
to a
it.
level that
Or just like do a lot of the heavy lifting, like, here's.
finding the
here's
functions that
actually-
exist. that-
Yeah. Exactly.
Awesome.
Oh,
How you been? I
Good.
feel like it's been forever.
it has been, the
Feeling
conference.
better?
Yes. Yes.
Oh yeah, how's the conference?
Great.
Awesome.
Yeah, mostly I just wanted to think, I've been feeling kind of terrible with my allergies, so I yesterday off. Doing this, but I'm also just in school. So I'm basically gonna like leave here, go to shall see.
If timing works out, I can drop your stuff off at 184, you know, I have to,
Oh, yes.
yeah, I'm going straight home after this, because I have to some appointment down with those two.
Oh, jeez.
Yeah.
Oh, yeah, the thing at the med school is like. Oh, so they went over this, I mean, like. There was like this report about. And I'm thinking about reading over the whole message and transcribing what you're doing.
Oh, cool.
I have a little bit of time to put it together. I think mine is getting pushed out till December or something.
Although August might be trying to switch with me.
Yeah, August. Oh, August, I'm trying to think of it.
Maybe.
Oh, for ARC, I would love to switch,
When are you getting your?
but it's Tuesday, so I understand, I can.
Well, the other thing that we could do is we could just summarize the. Talks and stuff.
That would actually be a phenomenal work.
That's.
What's the other one?
And we can see if the other.
Yeah.
That would be a really useful argument.
It's just like here's.
Not much.
Well, I mean.
Well,
The
the content,
we're recording, so just so you know.
Why would I put it?
Well, because every time I like mute myself, it's like, oh, do you want to record without? I guess I could just I'm gonna give it 3 more minutes. And I'm gonna start it. How are you?
Are you prepared? Are you prepared for?
Here.
I believe
immediately after we said.
Hello. Okay, I'm just gonna get started. So today I'm going to talk a little bit about some of the approaches that I use to make my analyses in R more reproducible. My name is Joselynn. I'm a genomics data scientist at the Computational Biology Core at the Center for Computation and Visualization. I started at Brown in early 2019. And before that, I got my PhD in biological and environmental sciences at the University of Rhode Island. And previous to that, the PhD, I had really no computational experience. And so the goal of this workshop is to kind of introduce to you a few of my favorite like packages and approaches that I've picked up over the last few years that have helped me to sort of make my analysis more reproducible. George isn't here, but I wanted to give them a shout out because they put together all the stuff about setting up jobs on Open On Demand. And they helped me to really kind of crystallize some ideas about how I use containers. So thank you, George, even though you're not here. If you have questions about anything that I talk about today, you can always come to our office hours, which are on the CCV calendar. In addition to like the general Oscar office hours, which are on Friday mornings from 10 to 12, we also have these like computational biology specific office hours that are Tuesday mornings from 10 to 11 and Wednesday afternoons from, I believe, 2 to 3. And you can come to the Comp Bio office hours even if you're not strictly a computational biologist. If there's someone who uses R quite a bit, we're probably the best people to kind of help you with your R questions. Okay. Let's see if this will work. There we go. So I think the 2 changes that have had like the biggest impact on the reproducibility of my analyses have been really being good about using some sort of version control. So I use Git and GitHub, and also using some containerization in my workflows. I'm not going to talk that much about Git, but I do want to sort of point you to, we gave a version control with Git workshop at the 2023 Research Computing Bootcamp. So I put the link there to that calendar so you can watch the video and check out the repo on that. So yeah, I'm not going to get into version control other than to say that you should absolutely use it. But I am going to talk a little bit about how I use containers. So when I've gone to other folks' talks about containers, they often describe them as a lightweight virtual machine. For me, it's just a really nice way to kind of like organize all of the software and packages that I use to do all of my analysis. I mostly use Docker containers. but those require like root or admin privileges. And so in cases where I can't get those privileges, like on Oscar, the Brown HPC, I run my Docker images as singularity containers. And if this is all very confusing for you, I'm just going to give a really quick overview of like the workflow using Docker. So you build a Docker image from a Docker file. This is a little bit small, but this is like an example of your Docker file, which is just a text file. And so you use Docker build to make your Docker image. And then you can push that Docker image to like Docker Hub or some other container registry, or you can use Docker run to sort of instantiate the computing environment that you've just sort of made a blueprint of making this Docker image. So once your image is on Docker Hub, a collaborator can then Docker run right from Docker Hub and sort of get the exact same computing environment to recreate your analysis. If you want to make changes, you go back and edit this Docker file, rebuild it, and then rerun and repush. Yeah, and like I said, if you want to spin up an instance of that container on Oscar or some other situation where you don't have root privileges, you are in luck because you can use the singularity pull and singularity run or exec commands to sort of run those Docker images as singularity containers. Any questions about that overall workflow? Yes.
What is the benefit of using something like Docker then, as opposed to just like having the same packages installed, or just saying like, yeah, I guess what does it buy? If anything, it could just be like a one-stop shop for like just rerunning the exact same.
Yeah, I mean, for me, the benefit is just that like it makes my analysis more reproducible, right? Because I have like multiple projects that sometimes need different packages, or even like I start them at different times, so they have different versions of R. And so it's nice because I can have like separate containers that have like different versions of R and different versions of like, you know, tidyverse installed. And then so, you know, things don't break if I upload tidyverse or if I update tidyverse, right? Because I have my container that has the like old version of stuff so that you can recreate. And it's nice too, because like it makes it easier for colleagues if they want to like reproduce what I've done. If everything's on Docker Hub and everything's on Git, and all my raw data is on like SRE or Geo, they can just do Docker run and use
everything from the file names, everything.
Yeah, it'll pull all the sort of compute environment stuff. So it makes
accessible by the way, or no?
Yes. So you can find this notebook on the GitHub repo, which is, I can paste it again. I put it in the, are you on Slack?
Yes.
Yeah, so I posted it in the I'll post it again. Let's see. Right there. It's the GitHub repo for today's talk. Boom. And then it's in this like notebooks folder. Okay. So yeah, like I said, most of the sort of raw data that I'm working with is going to be reads from a sequencer because I'm a genomics data scientist. So if all that sequencing data is uploaded to like SRE or Geo or some other like platform, and all my notebooks and scripts are on GitHub and all my Docker images are on Docker Hub, anyone else who wants to like reproduce the whole pipeline has all the data and the code and the compute environment necessary to like reproduce everything, which helps me sleep at night. So I would say that probably 99% of the time I'm using a Docker file that is based off of the images that are provided by the Rocker project. These are Docker containers that are designed specifically to be used with R, and they are wonderful. I'm a big convert. Here's an example of what a Docker file might look like. This is basically the Docker file I used for this workshop. So the first line is just saying, okay, from Rocker RStudio, which means that we want to use a Docker image from the Rocker org. We want the RStudio version, and we want to use the version that's tagged as having R version 4.3.1. That's what the little bit after the colon is. That's the tag. And then the next few lines are just installing some like system level libraries. You probably won't need to install these system level libraries depending on what you're doing. And then the last line there is just installing some R packages from CRAN. again, if you want to dig into this and start building your own Docker containers, you're welcome to come to office hours. We can help you get started with that. Any questions about any of that stuff before I move on? Great. Another thing that makes your analysis more reproducible and more sort of like interpretable by others is to sort of couple the data analysis with the code that was used to make it. So like you can put everything in a single R markdown file, but this gets sort of cumbersome and unwieldy as your analysis pipeline gets bigger and bigger and you have more and more steps. So you can use either Bookdown or Quarto to kind of like organize your analysis into these different chapters that are, you know, spread out across different notebooks. Quarto is very new and is particularly nice because you can use it with like R or Python or Julia or Observable. And it has lots of output format options and templates, including templates that make it easier to submit papers to journals, which is pretty cool. It'll do some like auto formatting for you. I did this workshop in Quarto, and so there's a file in this folder. So if you go into the notebooks book folder, there'll be a file called _quarto.yaml that spells out kind of all the options I used with Quarto. If you download the repo and you already have R installed, you should be able to like open the project and run this Quarto command to re-render the whole notebook, and then open this index.html file. Yes.
Can you have bash code cells in Quarto?
I actually don't know. I think you probably can.
You can put it in an R notebook.
Yeah, because I think there's actually ways to run like bash code even just in like an R markdown file.
You can do it some.
I don't remember what the exact command is. But I'll have to look into that and get back to you because I'm actually not sure. Okay, so this timing of pizza arriving is sort of fortuitous because if you want to try using the container that I made for this workshop, you can do that using Open on Demand. If you go to this address, ood.ccv.brown.edu, you can log in with your credentials. And on this landing page, select the RStudio Singularity app, which is like this thing that we've highlighted here. And then fill in these fields, leaving the others empty. In this example, I have number of hours is 48. You don't actually need 48. This could be like 1 or 2 if you just want to sort of check it out. And then this is the path. This is what you'd put in for the Singularity container path. And then the path for R executable could be something like this. This is just where R is going to save some like temp files for you. And it should look sort of like this. So if you want to follow along, go ahead and do that. Fill in this sort of that page as I've specified here in this text. And then you can hit launch. And then while it is in the queue, you can get pizza. So let's take a pause for like 5 minutes while people get food. I need to eat. I'm hungry.
Like shiny or
A little bit, yeah.
a little bit, yeah. Any question what hours and then goes where it's talking about the office hours.
Yeah.
Absolutely awesome.
Yes, John.
Our sealer, container seems to be not to start.
Uh-oh.
Starting and then they're saying the complete.
Ruh-roh. See. See if. Let's see. I see why. I see. What we need to do. Well, this is kind of fun. So I gave you the wrong file path. So I am creating a folder that has the correct path, and now you can see how I run Singularity Pull, which is maybe kind of fun. So yeah, Singularity is already installed on Oscar, so you don't need to do anything special. It should be like installed and loaded on all the nodes. So you can just run your like Singularity Pull commands. I feel like our best practices for like whether or not to run Singularity Pull on a login node or a compute node are a little bit fuzzy even to me. I always run my Singularity Pull commands on a login node. Sing has told me, yeah, Sing has told me that they're beefy enough. Yeah, so I think it's okay to run your Singularity Pull commands on a login node. So we're going to do Singularity Pull. The name should be reproducibility_r.sif. And then I'm pulling it from Docker on BioCore. I might need to actually look at Docker Hub. Reproducibility R NO tag. Let's see. Okay. So you can see that I've pushed a few different versions of this container. I want the most recent one. And so the tag I used was this date. Okay, Singularity Pull. There's the CIF. We're pulling it from Docker. Okay. You should be good to go now. If you go back here and try to, this container exists now. It didn't before. My apologies. Thank you, John. Let me know if you run into any other issues. I can wait a few more minutes. We love to see it. Okay. Where was my notebook? Okay. So now this container exists. You should be able to start up your container. Delightful. Okay. The first package I want to talk about is the here package. This is one that is sort of handy for dealing with file paths. When you look at someone else's R code, you might see scripts or notebooks with lines that look like this, where there's like a hard-coded path where I'm saying, okay, read this table from users Joselynn desktop raw data.txt. If I give this notebook to August or Eric, and then they try to run this code, it's not going to work for them because obviously users Joselynn does not exist on their computer. You might also see something like this, where they run this setwd function, which will like set the working directory to some directory here, like I'll say, okay, set working directory should be users Joselynn desktop. And then I could do like read.table raw underscore data.txt, and that would be fine. And approaches like this aren't like wrong per se, but they're definitely a little bit fragile. And again, they're going to break, or they could break when your colleagues try to run your code on their computer. So one way to avoid this whole mess is to use RStudio projects with the here package. RStudio packages are nice, or projects are nice, because they let you keep kind of like separate working environments for each of your different analysis projects. And they do, I don't really want to dig into the weeds too much on projects, but just they support, there's a lot of other really nice things that they do for you. Like they'll keep track of your art history for all your different projects and stuff like that. Oh, there's someone trying to get in. Can someone open that door for this person who's trying to get in? Thank you. Okay. You can start up new RStudio projects either through the RStudio app. So there's like you can just do like file, new project, or you can use the use this package, which will has like a function to you can make a new package or just a new project that's like an analysis project. Again, you can open this project if you are in RStudio and you go to File, Open Project, and open this reproducibility underscore R project, which is in the like base folder of this repo, the root folder of the repo. And now once you have the project open, you can use the here package to refer to paths like this, where you can just say, okay, this double colon notation is basically just saying look in the here package for a function called here. And then you can sort of build up full paths like this, where you would just put in parentheses, you'd put sort of like the subdirectories that you want to look for or look in. And you can still do things like set WD to change the working directory, and that actually doesn't break how here works. So here I'm just saying set the working directory to be my home directory, and then when I run here, it still knows that that sort of the folder for this project is this reproducibility R folder. Any questions about that? Great. The other package that, yeah, go ahead. Yes. Yes. Yes, please do, because this is my last piece. So don't be shy. I maybe made this one too short. Yes.
So here we'll give you the R project is.
That's right.
Well, what if your data is?
You can, I think, set it to be, I think there's like a function called I am.
So that everything's relative to that location.
Yeah, so you can build paths relative to that like top level directory, and then you can also do this one. So you can say, okay, I am, and then say, okay, give it sort of the path to the current like script that you're. Does that make sense? Thank you. Okay. The other package that I discovered pretty recently, actually, thanks to August, is this package called AssertR, which is basically a suite of functions to sort of make sure that your data meets some of your like assumptions before you proceed with your analysis. So, you'll hear people who write, I don't know, software talk a lot about how they write tests. And sometimes that is hard to do or maybe doesn't apply in situations where you're writing analyses. And I feel like this is one nice way to kind of like test your data before you start running your analysis on it. So we can load this MT cars data. And so this MPG column is the miles per gallon for all these different models of cars. And it's an example of data that like counts or something should never have negative values, right? So maybe you want to do something where you check to see sort of like you want to run some stats to summarize the miles per gallon grouped by the number of cylinders in the engine. What would happen if this was not true, right? What if some of these values were negative? We can kind of mess with the data a little bit to see what happens. So here we're just making this fifth entry into a negative value. And then if you open up this notebook, I actually don't have this code being evaluated, because if this chunk is evaluated, the whole thing fails, because we've just made it we've just made assert R test for a thing that's not true. But basically you can use this assert R verify function to say, okay, check to make sure this MPG column is always greater than 0, and then run my group by and my summarize functions. And if you run this code chunk, it'll give you back a error message. We're stopping running this notebook. Our assumptions aren't met. And there's lots of, I'm only giving the like most base example from their docs, but they have a lot of other functions that get a little bit more sophisticated about sort of verifying things about the rows of your data or the columns, or you can get a little bit more sophisticated than this with your tests. Does anyone have any other questions? This is all I put together, so feel free to ask. If you have any questions about any of the stuff we've talked about, or if you want help building your containers to run your R code, don't be shy, come visit. Happy to help. Yes, John. Yes.
Can you maybe say something about what are the pieces in the all the pieces in overview to make the research that you do today reproducible tomorrow?
Oh,
What's in the what goes in the repo,
sure.
and is there a standard format for that kind of thing, so that you can hand it off to someone else and they'll also be able to.
No softballs from John. We love it. I feel like if you want your analysis to be reproducible, you have to make sure that people can access like the raw data in some way. You want your raw data to be something that you can read in, but that you never like mess with, right? The raw data is sort of this like precious thing. So people need access to that. They might need access to like intermediate files. For example, when we run our RNA-seq analyses, we like work with our raw reads, we trim them, we align them to our reference, and then one of the things you get back out is this like counts table. It's probably good practice to like make sure that all of your scripts for all of your intermediate processes are all in GitHub, and that those intermediate files are available for folks. You want to make sure that, again, people have access to the same exact versions of the software that you've used. So like if you don't want to use Docker files, you could use something like Conda, or I think there's like renv, which is kind of similar to Conda in that it's like environments for R. And so those will output like YAML files or something that people can use to recreate all the packages you used. Yeah, I mean, raw data code to process in intermediate files. Documentation of like, here's how you run all the steps. What am I missing?
Well, you document it's nice if your files are ordered.
Yep. Yeah, so for folks on the Zoom, August is talking about how one other thing you can do to make your analysis more reproducible is like, if you have a folder that has all of your scripts that people need to rerun your analysis, it's helpful to sort of like name the scripts in such a way that the order that you run them is clear. So like the first script would be like 1_trimming or something like this. That's a good point. Great. Thank you all.